Welcome to Wisdom Learnings, 10th class Karnataka CBSE NCERT class syllabus. First chapter we are discussing. Previous class we are discussing about the introduction, and now we are discussing about fundamental theorem of arithmetic. What is saying fundamental theorem of arithmetic? We can discuss today's video about fundamental theorem of arithmetic. The theorem says every positive number can be expressed as a product of primes and its factorization is unique from the order in which the prime factors occur. What is the meaning of this one is any positive number, that means any natural number we can consider as a product of prime. What is the prime number? Prime number is nothing but is the only two factors. The prime number has only two factors. Which are they? The prime number has only two factors means they are 1 and itself. For example, 2 is a prime number. What are the factors of the 2? 1 and 2. Similarly, what is the prime number? 3 is the prime number. Then what are the product factors? 1 and 3. Similarly, 11 is another prime number. We can product write 1 and 11. So that means only two factors. 1 and itself a number have the factors. That numbers are called prime number. Then what is the fundamental theorem saying? Every positive number can be expressed as a product of prime. That means, for example, I am writing a number 12. We can write the product. How to find that one? We can divide the number by the prime numbers. So first prime number is 2. 12 is an even number. So we can divide 12 by 2. 2 divided. Then what getting answer? 12 divided by 2 is 6. Again, we can write 2. Again 2. 6 divided by 2 is equal to 3. So 12 we can write in the product of prime number. That means 2 into 3. That means 2 how many times repeated? 2 times. Therefore, 2 raised to 2 into 3. So 12 has the we can write as the product of the prime number, that 2 square into 3. This is the unique. No other positive number getting this type factorization. One more example we can take 15. 15 we can write, 15 is the odd number and ends with 5. We can easily divide it by 5. Divided by 5, what is getting? 5 3s are 15. So we can write 15 is equal to 3 into 5. One more example is there. We can write 144. What happened? 144 is the even number. So we can divide it by 2 is easily. So we can divide it by 2. That is getting 14 divided by 2 is equal to 7. 4 divided by 72 getting. Then again we can, 72 is an even number. We can divide it by 2. Again 2. 72 divided by 2 is equal to 36. 36 is an even number. Now we can divide again by 2. 36 divided by 2 is equal to 18. 18 is again an even number. Now we can divide 18 by 2. That is equal to 9. 9 is the odd number and we know that 9 is the multiples of 3. So divided by 3. 3 and 3. So we can write 144 is equal to 2 into 2 into 2 into 2 into 3 into 3. That means 2 into 2, how many times 2 repeated? 4 times. That means 2 raised to 4 into 3, how many times repeated? 3 square. So 144 we can write the product of the prime number, that is equal to 2 raised to 4 into 3 square. So this is the fundamental theorem of arithmetic. Using fundamental theorem of arithmetic, we have to find LCM, HCF. That is the next chapter. So before that, I giving some questions to you for practicing the factorization. I give the question here. You do, and one thing you do the question and give the answer as a comment. First question, homework question. This is homework question. Then you can practice the factorization. Then only you can easily find the LCM and HCF. So don't regret for doing the homework. Compulsory want to do properly. First question, 52. Second question, what is this? 95. Third question, 256. Fourth question, 72. The 4 questions are giving to us a homework for practicing. You have to complete the problem and comment it to me as an answer. Then I will continue the next class as finding the LCM and HCF, properties of LCM and HCF, and how to find what are the questions are coming in the last year. We are discussing about that one. So now I am winding this chapter. This is a small video. You have the practice, then only we can go front. Okay, thank you one and all.